Hello, YouTube. This is Mr. Bakari, and today we are going to talk about graphing tangent and cotangent. So, what I'd like to start with is establishing the parent function. Okay. So, first off, let's talk about the period. So, with the other four trig graphs, you find the period is 2 pi. So, that is sine, cosine, secant, and cosecant have a period of 2 pi. Now, if you look at the unit circle here, you will notice that tangent y over x at 0 radians is 0. And then as we move to pi over 2, it's undefined. And then as we move to pi, it's back to 0. And this repeats every 180 degrees versus 360 degrees. So the period is not 2 pi, it is 1 pi. Okay, so because of that, we take our period of 1 pi, we divide it by 4, and we come up with these four steps: 0, pi over 4, pi over 2, 3 pi over 4, and pi. And I've established that here on the x-axis. So this is one period. Okay, I've got my high, my mid, and my low line at y equals 1, 0, and -1. And now we will piece together the parent graph of tangent. So y over x at 0 radians is 0. Okay. Now we move to the second step, pi over 4, and you'll notice the coordinate is square root of 2 over 2, comma, square root of 2 over 2. And if we divide y over x there, we simply get 1. Okay. Moving to pi over 2, y over x, 1 over 0 is undefined. So at pi over 2, we have a vertical asymptote. Okay, moving to 3 pi over 4, the coordinate is negative square root of 2 over 2, comma, square root of 2 over 2. So if we divide y over x there, we get -1. And then we arrive at pi radians, y over x is 0. Okay? So as we approach the asymptote from the left, cosine is getting smaller and sine is approaching 1. So our graph is approaching positive infinity. And we get the same trend down here. And there is one period of tangent. Okay? So let's graph the parent function for cotangent, which is x over y. So we're going to do the same thing. We have the same setup. At 0 radians, x over y is undefined. All right. Now, as we move to pi over 4, x over y, divide, we get 1. Okay, at pi over 2, x over y is 0. 3 pi over 4, x over y is -1. And at pi, x over y is again undefined. So we have a vertical asymptote. Okay, and so we approach our asymptotes on both sides just like this. And that is one period of cotangent. Okay, so what are the main differences between the two? Well, cotangent starts in the middle, and cotangent starts with an asymptote. It's undefined. Okay, and as you can see, the graph goes low to high as it approaches from the left to the right, and with cotangent, it goes from high to low. Okay? So this is a infinite graph. This is just one period of each. All right? And remember, the period is pi. But now that we'll be looking at transformations, if there is a horizontal stretch or compression, we're looking at pi over b. And that will be a period change that we've seen in the previous videos for the previous functions we've done. All right, so let's look at some of these transformations. So here is a tangent graph. And as you can see, there is a period change, okay? This is our b value. So what we're going to do is we're going to take our period, pi divided by b. So pi over 2 is pi over 2. So our period is pi over 2. Now, our step is always our period divided by 4. So if we take pi over 2 divided by 4, we have pi over 8. Our start is our horizontal shift. Okay, so that is x equals negative pi over 3. And our amplitude is 2. Okay, your amplitude can be found in front. It's your a value. So amplitude of 2. That is a vertical stretch by a factor of 2. Now, we always want to find a common denominator for our step and our start before we label our angles on the x-axis. So I'll go ahead and do that. That's going to be 24th, so that's going to be 3 pi over 24 and negative 8 pi over 24. So we start at negative 8 pi over 24, we step 3 pi over 24. So we're going to graph one period here starting at negative 8 pi over 24. And we will step 3 to negative 5 pi over 24 to negative 2 pi over 24 to positive pi over 24 and one more step to 4 pi over 24. Okay? 5 points, 4 steps, 1 period. And it should be pi over 2. You can check that. Looks good. And now I'm going to bring in my midline. My midline is going to be at negative 2 because my vertical shift is down 2. And then my amplitude says to go 2 above. So that will be at 0. And 2 below, which will be at negative 4. Okay? Raise that up a little bit. Now you can go ahead and label these. I like to label these on the left. That is y equals 0, y equals negative 2, and negative 4. All right. So we're graphing tangent, and tangent starts on the midline. Okay. So that is going to be right here at our start, negative 8 pi over 24. And then you want to recognize the pattern of the parent function. That's one thing you want to study before you start transformations here. So it goes mid, high, undefined, low, mid. Okay, so we'll draw our asymptote. And that's the pattern of tangent. So let me connect these. And there is one period of tangent. Now we'd like to circle our starting point so we can establish that this is a tangent graph. So once I circle that, now I can see, okay, this is tangent, starts on the midline. And I can see it's one period to the right. Okay? All right, let's look at a cotangent graph. Now this one, as you can see, we need to factor this. So if you look inside parentheses, if you've got two terms and your leading coefficient is anything other than a positive 1, you need to factor that out. So I'm just going to rewrite this. And I'm going to factor out the 3. 3 times x is 3x. What times 3 is going to give me negative pi? So think about that. Negative pi. That would be pi over 3. So check that, distribute the 3, and that should check out, and we're good. So as you can see, it's misleading here. Now we can see that our graph starts at x equals pi over 3 and not pi. Okay? So you've got to work with the factored form here. Now let's go back up to the period. So the period of cotangent is pi, but remember it's pi over b. Well, b is 3. So our period is pi over 3. Now we divide that by 4, and we get pi over 12, and that's our step. Okay, amplitude is 1. Look in front of cotangent here. A is 1. And now we're good. Now we want to get a common denominator with our step and our start. So it looks like we're going to do 12ths. So I'm just going to write pi over 12 is my step. And for my start, I'm just going to write a third as a 12th, which would be 4 pi over 12. Okay? Now I'm going to label my x-axis. I'm going to start at 4 pi over 12 and step pi over 12. So 5, 6, 7, 8. 4 steps. Bring in my midline. So my midline here is 0 because there is no vertical shift. My high line is at 1 and my low line is at -1 because there's no amplitude change. I can label those here as 1, 0, and -1. I'm starting at 4 pi over 12. This is cotangent. Cotangent always starts undefined. Okay, scoot that over. And then cotangent starts high, mid, low, undefined. But it's been flipped. So instead of starting high, we're going to start low. So let's do this in green, low, mid, high. And at the end of our period, it's always the same as the start. So it's undefined again. So if I connect my points here, showing heading towards negative infinity on this side and positive infinity on this side. That is one period of this cotangent graph. I'm going to circle my starting point, which is at 4 pi over 12. I like to circle the top if it's an asymptote, just so we can see it. And we are done. All right. So join me in the next video with tangent and cotangent. We will look at a few more challenging transformations, and we will graph maybe 2 periods. All right. Hope to see you soon.